Welcome to 6.10, Properties of Logarithms. So we're going to look at three properties today, and we're going to talk about condensing logs into a single log with a single argument. So what we need to do is familiarize ourselves with those three properties. The first property is called log of a product property. So if we have log base b of x times y, so our argument is x times y, we can break it up into two logs. We can say log base b of x plus log base b of y. So what we would call this is the condensed version on the left, and on the right is the expanded version. Okay, so that's our first property. And what we can do is we can compare that to exponentials. When we're multiplying bases that are the same, we add the powers. When we're multiplying arguments with the same base, we can split it up and add the two log terms. The next is log of a quotient property. So this is log base b of x divided by y. Here's our condensed version. If we split it up, notice now we're subtracting. So again, it's similar to our exponential properties here. Then we have log of a power property. So this is log base b of x to the n. What happens is we can take this n and move it as a coefficient of that log term. So it becomes n times log base b of x. Let's try a few examples where we're going to now write the expression as a single log of a single argument. So only one log term, and we're going to simplify that argument as best we can. So let's first look at this first example here. Log base 2 of 3 plus log base 2 of 5. Notice the logs have the same bases, so we can combine the arguments. So we would get log base 2 of, now I take a note, what are we doing to these log terms? We're adding those log terms. So what are we going to do to the arguments? We're going to multiply those arguments. So it becomes 3 times 5. Okay, and now we can simplify. 3 times 5 is 15. So we get log base 2 of 15. And there's our answer. Let's zoom over to this next example on the right here. Log base 5 of 4 plus log base 5 of 8 minus log base 5 of 2. So how are we going to condense these? First, I double check that all of my bases are the same. Since they are, we can go ahead and combine our arguments. So how are we going to do that? Well, we can do it a few ways. We can first focus on the first two and then worry about that minus log base 5 of 2 afterwards. So how are we going to condense those first two? Well, since we're adding the log terms, we're going to then multiply the arguments. So it becomes log base 5 of 4 times 8. All right, then we have this minus log base 5 of 2. Okay, so now we can clean this up. We know 4 times 8 is 32, but now we're subtracting these two log terms. So what are we going to do to those arguments? Hopefully you recognize we're going to divide them. So we get log base 5 of 4 times 8, we get 32, divided by 2. Okay? So now the last thing we have to do is just simplify completely. So 32 divided by 2, we end up with our final answer, log base 5 of 16. And there we have it. All right, let's go on to the next example and see how we do here. So this time we have 6 times log base 5 of 4. So what I notice is we've got this coefficient. So remember the rules. If we have this coefficient, what we can do is we can then move it to the power of our argument. So this really becomes log base 5 of 4 to the 6th power. And now we just have to determine, well, what is 4 to the 6th power? And if you don't know that off the top of your head, you should get 4,096. So we get log base 5 of 4,096 as our final answer. Okay, I want you to try the next 3 examples on your own. So you need to complete this example, this one, and this one. All right, condense completely, and then when you're done, check back and see how you did. Okay, how did we do? So hopefully with this first example that we looked at, we condensed everything correctly. We moved the 3 to the power, all right, and we got 216, so 6 to the third. And then since we're subtracting, we're going to divide the arguments and we simplify. So we get log base 12 of 54. Moving on to this next example over here, I did a few things in one step. I combined these first two by dividing the arguments. At the same time, I moved the coefficient to be the power of 3 of that argument. So we get log base 2 of 625 divided by 125 plus log base 2 of 3 cubed. Well, 625 divided by 125 is 5, and 3 cubed is 27. At the same time, though, since now we're adding these logs together, I can multiply the arguments. So we really get log base 2 of 135. Okay, this last example here, how many of you stopped right here? Okay, or do we notice anything about the relationship between 6 and 36? So there's kind of 2 ways we can go about it. I can rewrite this as log base 6 of 6 squared, right? And if we recall those properties, when the base of the log is the same as the base of the argument, we are simply left with that power. So this actually goes to 2. The other way we could have looked at it is we could have said, okay, log base 6 of 36, let's just make sure we can't simplify this any further, so we can set it equal to x. And then we convert from log form to exponential. So we would get 6 to the x equals 36, and we know we need to get common bases. So we would get 6 to the x equals 6 squared. And now that the bases are the same, we can zoom in and set those powers to be the same. Either way, we can simplify this log expression further. This next section we're going to need our calculators for, so make sure you have those handy. What we're going to do is we're now going to solve exponential equations where we can't get the common base. Okay, so we're going to talk about, well, what do we do? Because we always try to get common bases first, but that's not always going to be possible. So for instance, if we zoom in and we solve 3 to the x equals 29, my first goal would be to get 29 to rewrite it as 3 to some power. There's no way we can do that without having our powers be decimals. Okay, so what do? Well, when we can't get common bases, what we do is we take the log of both sides. So what's that going to look like? Well, that means I take the log of the left side. So it's the log of 3 to the x equals the log of 29. Okay, so I just took the log of both sides. Now we're going to use any properties that we can. And I notice we've got this power. We're going to move that out front. So now that becomes x times the log of 3 is equal to the log of 29. So how do we get x by itself? All we have to do is divide by the log of 3. So we get x is equal to the log of 29 divided by the log of 3. Okay, now we can't combine these necessarily, all right? We could use our change of base formula, but we'll leave it at this for now. Now is where we get our calculator out, and you should find a log key right next to your number 7. So you take log of 29, don't forget to close the parentheses here, divided by log of 3, close those parentheses. And when you plug this into your calculator and it said to round to 3 decimals, we should get x is about 3.065 as our final answer. Okay, I want you to try this next example on your own. The only difference is now our power is 2x. So be careful in your final step of getting x all by itself. Try it on your own, check back, and we'll compare. Okay, how did you guys do? So we have to take the log of both sides because there's no way we're going to be able to rewrite 456 to 1.96 to some power. So we take the log of both sides. The next step is to move this power, 2x, out front. So now we have 2x times the log of 1.96 equals the log of 456. To get x by itself, we have to divide by 2 times the log of 1.96. So make sure you put parentheses around that entire denominator, otherwise you're going to get a different value. So if you didn't get 4.549, you may not have put parentheses on your calculator in the denominator. Double check that now, and if you have questions, let us know. Okay, so this last problem, what we should notice is we have 17 times this exponent. So before we can do anything, we need to isolate that guy, which means we need to divide by 17 on both sides. So we get 2 to the 5x equals, now if you were to plug 1639 divided by 17 into your calculator, you're going to get a decimal, and I don't want you to round. So we are going to keep it the exact value, 1639 over 17. Now, I don't know about you, but I don't think we can get common denominator or common bases very easily. 1639 over 17, I don't know that I could raise that or change that to 2 to some power. So I want you to take this from here. Take the log of both sides, be very careful, plug it into your calculator, and round to 3 decimals. Let's see what you get. Check back when you're done. Okay, so how'd you do? First thing, I kind of did 2 steps in one. When I took the log of both sides, I also moved that power out front, and that's totally fine if you jump straight to that. All right, so take the log of both sides, and now to get x by itself, I have to divide by 5 times log of 2. Remember when you're plugging into your calculator to put parentheses around your entire denominator, and what you should get is x is approximately 1.318 if we round to 3 decimals. If you have any questions on this, let us know.